Consider the function given by f of x equals 4x cubed minus 9x squared minus 30x plus 25 is a big function. Okay, so what are we doing? We're finding any critical values. Okay, so remember, critical value, you find the derivative and you set that equal to 0. So to find critical value, we start with the derivative. Using power rule, we'll get the derivative to be 12x squared minus 18x minus 30, right? Now, you're going to set that equal to 0 and solve for x. Now, this may not be a good news for some of us who do not enjoy factoring, but hey, we have to practice. All right, let's try this. I noticed that 12, 18, and 30 are all divisible by 3. So let me at least try to factor out the 3. If I divide 12 by 3, I'll get 4. 18 divided by 3 is 6. 30 divided by 3 is 10. Okay. Now I still have this trinomial that I will try to factor on the side, okay? I strongly believe this is factorable. So let me factor 4x cubed squared minus 6x minus 10 over here on my scratch work using AC method. So I multiply this 4 to this 10 temporarily, okay, to get us started. X squared minus 6x minus 40, and I will factor this. Two numbers that multiplies to be 40, but they have to add up to 6. 10 and 4, right? 10 times 4 is 40. If I make 10 a negative, 4 a positive, I'll be able to get negative 6 when I combine them. All right, I need to now divide both of these by that 4 that I multiplied in the beginning, right? I can reduce this first fraction, x minus 5 half, right? The second one, I can write it as x plus 1. Now, I will bring this denominator, this bottom up. That's why this factoring is sometimes called bottoms up method. But if I bring that up, I got the final factored form to be 2x minus 5 and x plus 1. So this is just my scratch work doing the factoring. Doesn't matter how you guys factor. Some of you guys just guess and check, and that works fine. But that is my scratch algebra work, which got my trinomial down to 2x minus 5 and x plus 1. Whew. Now I'm going to set each of these factors equal to 0 to solve for critical value. So when is 2x minus 5 equal to 0? When that factor is equal to 0, right? So when x is positive 5 half, we have a critical value. Another critical value will happen when this x plus 1 is equal to 0. And that happens when x is equal to negative 1. Okay? So we found critical values. What we will now need to do is divide up our number line using these critical values. So look, wrong number line, which number is smaller? Because smaller number always goes to the left. So I'm going to put negative 1 on the left, because that's a smaller number. And I'm going to put 5 half on the right. So that's a positive number. Now, we need to do the first derivative sign test. Okay? The first derivative is f prime of x equals, and I'll copy this line down, okay? The factored out form, okay? 3 times 2x minus 5 times x plus 1. So what we now need to do is do some test points to see if the sign of the first derivative comes out to be positive or negative. I will start from this side all the way on the right. What is a number that is bigger than 5 half? Okay? 5 over 2 is 2.5. So I can just pick x equals 3, right? Or you could really pick x equals 10. That's fine with you. If I plug in 3 into the first derivative, let's see what sign we get. Okay? So that will be 3 times 2 times 3 minus 5 times 3 plus 1, right? That is 3 times 6 minus 5 is 1. 3 plus 1 is 4. So if I multiply these three numbers out, then I will be getting a positive sign. And positive first derivative means the function is increasing. So to the right of 5 over 2, this function is going up. Now, in between negative 1 and positive 5 over 2, in fact, in between any negative and a positive number, there lives a 0. So I will pick 0 to be my test point. If I plug in 0 into the first derivative, I will get this expression. All right, let's simplify the sign now. This will be 3 times negative 5 times 1. Well, because of that negative in the middle, the product comes out to be negative. And negative first derivative means the function is decreasing in between negative 1 and 5/2 in this case. Okay? All right, let's do the last checkpoint that is smaller than negative 1, to the left of negative 1. I will pick x equals negative 2, because that's smaller than negative 1. What happened if I do my plug-in? So 2 times negative 2 minus 5, negative 2 plus 1. All right, let me be careful here, okay? So that is 3 times negative 4 minus 5. And the last parenthesis is negative 1. And this becomes 3 times negative 9 times negative 1. And I can see when I multiply those two negatives together, the sign will come out to be positive. So this is increasing. So I can sketch a graph here, okay? I can sketch a graph that looks like this. Increasing, okay? You stop right there. Stop, 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 stop. But from that point on, you go down, decreasing. And you stop, stop, stop right there. And then again, to the right of 5/2, you go up, okay? So here is a graph of f of x, a sketch of f of x. And we're going to use this to answer these, fill in these blanks, okay? F is increasing over the interval, the green and red. Negative infinity to negative 1, union, 5/2 to positive infinity, right? That's going up in the green and the red region. And it's decreasing over the interval, that orange section, in between negative 1 and 5/2. All right, the relative minimum, relative maximum at point. What's the max? This one, right? The maximum happens at x equals negative 1. But I don't know what the y value is, so you will have to plug in negative 1 into this function to find the maximum, okay? I know the minimum happens at 5/2 for the x value, but now I'm going to zoom back in so that I can find the y values of negative 1 and 5/2. And when you're finding the y values, don't be plugging them back into the derivative function. Go back to the original function, because that's how you find the y values, right? So here, let me see. I'm going to find what the y value is. I'll do 4 times negative 1 cubed minus 9 times negative 1 squared minus 30 times negative 1 plus 25. Wow, okay, that's pretty high up there. So we have a maximum way up at 42. So that's going to be the maximum point. Now let me plug in 5/2 to get the y value, okay? So instead of negative 1, I'm changing all these to 5/2. 5/2, everyone. All right, that comes out to be negative 43.75. I wish they can give me a fraction. Yep, right there. The fraction value is negative 175/4. But I do want to see if I can get these from the graphing calculator too. So I'll jot down the decimal value. The decimal was negative 43.75. So let us check our answer. So we got everything. We have a pretty good idea of what this function should look like. Got the max and the min. But what does the graphing calculator will show us? F of x equals 4x cubed. So this is me just checking my answer, okay? All right, so it's a pretty steep graph, okay? I may change the y-axis a little bit. Yeah, I'm gonna change the y-axis a little bit so that we can see the picture. All right, look at this for me. Here's the graph of a picture of the function, okay? We have that N shape, right? That's good. All right, let's see if the max really happens at negative 142. Click. Yes, we got it right. The max happens at negative 142. And the minimum, we are expecting it to happen at 2.5 and negative 43.75, right? Let me click on that. There we go. So we don't need a graphing calculator anymore. We can graph a whole function. We can at least have a sketch of it using calculus, right? So this was a pretty big example that took me about a whole 10 minutes, okay? But try, practicing this. I do want to put a question like this on your third exam. But I'll show you another one on page 128 in another video. Okay?